Right, next we'll see the second question, second part. You know that series problem frequently every exam papers. We have the summation of series. So here, 5 over 4 into 1 square into 2 square plus 11 over 4 into 2 square into 3 square plus 19 over 4 into 3 square into 4 square and so on. They have set the general term also here. General term UR is provided. Such a method. You see here 4, 4, 4 there. So R square. Here 3 means 4. 2 means 3. 1 means 2, right? Therefore R plus 1 square. Also numerator provided at a quadratic pattern R square plus 3R plus 1. So that's the common term here, right? UR equal R square plus 3R plus 1 over 4R square into R plus 1 square, right? So there's a problem here. They ask this UR, the form f of R minus f of R plus 1, right? UR equal to f of 4 times U f of R. So if I cross multiple, 4 times UR equal to what? R square plus 3R plus 1 over R square into R plus 1 all things square, right? So now the problem is show the lambda. There's a lambda. They said 4UR equal f of R minus f of R plus 1. There's such a pattern. Find the lambda. They said what is f of R? F of R equal R plus lambda over R square, right? F of R equal R plus lambda over R square. Also the relation then, if I write here, can you say this? The relation 4UR equal to F of R minus F of R plus 1, right? You know, most of the problem, this is the pattern in series. They'll give some pattern f of R minus f of R plus 1 or VR minus VR plus 1, like that pattern. If you find that issue, if you resolve it, then problem becomes simple by applying 1, 2, 3 and so on. Find the summation, all cancel off. You can find the rest of the answers, sigma or summation, right? So first occasion, you should find the lambda. So use this formula. What is 4 times UR? Can you say this? What is 4 times UR? R square plus 3R plus 1 over R square into R plus 1 square, right? Equal f of R is R plus lambda over R square. Then what is R plus 1? So if the f of R is provided, what is f of 1? Put R for 1. If f of 2, put R for 2. F of 0, put R for 0. F of x. So R for R plus 1, apply that. Therefore minus here, R for R plus 1, right? R plus 1 plus lambda over R square, okay? So we simplify using multiply the LCM, multiple by the LCM. Then you have R square plus 3R plus 1 equal here R square cancel, R plus lambda into R plus 1 all things square. I erase this all now. Okay, minus here what R square cancel, R plus 1 square into R plus 1 plus lambda, right? It's a polynomial pattern. So by using any mode of solving, simplifying, find the lambda value, right? Is it okay here? Here what is R plus 1 square, right? Here R plus 1 square. Then this is R plus lambda into R plus 1 square minus this cancel. You multiple R square, right? R square into R plus 1 plus lambda. So what the simple idea to calculate the lambda, if you make R4 minus 1, put R4 minus 1, this part is equal to 0, right? Apply R4 minus 1, this becomes 0, then transfer a lambda value, right? So if R equal minus 1, if R equal minus 1, here what is that? 1 minus 3 plus 1, here 0, minus here R4 minus 1 mean plus 1, R4 minus 1, 0 lambda, right? Is it okay? So what the lambda answer, lambda equal is what? 1, 1, 2 here, 1. Is it check that? Lambda is 1, right? Lambda equal to 1. So lambda is okay. Then find the sigma UR. So you know the method now. 4 times UR equal f of r minus f of r plus 1. That's the standard form here to find the summation, right? Everything clear to find the summation. Then now we apply 1, 2, 3. If you continuously apply the values up to n, generally first 3 terms and last 2 terms enough, right? So it becomes the sum of the all values. So what is n for 1? 4 r for 1. Put r for 1. 4u1 equal f of 1 minus f of 2, right? Next put r for 2. That is 4u2 f of 2 minus f of 3. Next r for 3 u3 f of 3 minus f of 4, right? So and so on. Better you write the last 2 terms. What are that? R for n minus 1, right? 4u r for n minus 1 equal f of n minus 1 minus f of 1 more, that is n, right? At last r for n, right? So 4un equal f of n minus f of n plus 1, okay? Now summation, sum everything. So here what is that? 4 into u1 plus u2 plus u3 plus up to un. This can be shown as sigma notation, right? There is 4 into sigma r equal 1 to n, r equal 1 to n. See the other side here, f3 cancel, this pattern I think all cancel, right? First column f of 2 there, first column f of 2, the last column here f of n plus 1, okay? This is the expression finally to find the sigma ur, right? Is it okay? Here f of 1, there f of 1, sorry, f of 1, right? Therefore find the summation. So I show here therefore 4 into sigma ur r equal from 1 to n. What the answer? What is f of 1? You know f of r, you know the f of r? F of r is what they said, f of r plus lambda over r square, right? F of r is r plus lambda plus r square. So we count that lambda is 1. Okay, lambda is 1. So r also f of 1. So 1 plus 1, 2. There that is half, right? That is half, okay? So answer half minus f of n plus 1. You read here f of r plus 1 is what? You know the lambda value. Therefore apply for that. F of n plus 1 is what? N plus 1. Okay, this here r for 1. Lambda also 1, 1, 1, 2. That's 2. Let's try 2, 2. That is 2, right? F of 1 is 2. Check that. Here's f of r. Put r for 1. Lambda also 1. 1 plus 1, 2. Below that 1, right? What is f of n plus 1? You know the f of r plus 1? Put r for n plus 1. That becomes n plus 1 over n plus 1 all things square, is it? Okay, this is the ur answer. 4 times ur. Therefore, sigma ur answer r equal 1 to n. 1/4 into 2 minus n plus 1 over n plus 1 all things square, right? is the final sigma UR. Always after completing such a problem, they ask whether the series is converging or divergent. So but the idea I apply n for infinity. So in this case, if you use by dividing by the highest power, this becomes 0, this part becomes 0, right? So if n tends to infinity, sigma UR r equal 1 to n, 1 to infinity now, becomes what? Here, this one, right? Half, that is half, right? Therefore, the series we call Convergence Series, because sum of the value become a constant, approach to a constant. Such a case we called convergent, right? Here this becomes 0 if you divide by up and down by the highest power n, and simplify below a number below z, become completely entire 0, right? This is the answer, 1/4 into 2, that is half, right? This is a series question, right?